Hello, good evening. This is Dr. Swapna. Welcome to your Learn Lab, your one-stop for learning. In today's video, we'll be learning about inferential statistics. This is the topic from the very first unit of the very first block of BPCC 108. In this video, we'll be learning what is inferential statistics, different concepts that are involved in inferential statistics, and in the end, we'll also look at what kind of different questions have come in the PYQs or the previous year question papers. So without much ado, let's go and check out what is inferential statistics. Let's look at the concept and meaning of inferential statistic. Inferential statistics is a statistical method used when to carry out bivariate analysis where there are two variables. Bivariate analysis, in the name itself we know bi is two, variate involves variables. So any analysis which involves two variables, we use inferential statistics. When there are multiple independent variables and dependent variables. Okay, if there are like more than two independent and dependent variables, in that case also we use inferential statistics. Statistical method used to study cause and effect relationship. So you are studying variables wherein you want to see if they have a cause and effect relationship between each other. There also you use inferential statistics. Inferential statistics can be used to make estimations and predictions. What is estimations? Estimation is calculation or finding out something. Prediction is without, even before something happens, you were saying okay, this is the probability of what might happen in future. This is called prediction. Continuing with the concept and meaning of inferential statistics, we have a couple of textbook definitions of inferential statistics here. In case you get a question asking definition of inferential statistic, it would be better if you can quote any of these textbook definitions. The first one we have by Salkin 2014. What does he say? He says it's a statistical method using which inferences can be drawn about the population of the study based on the characteristics of the sample on whom the study was carried out. Let's break this down so that it will be easy for you to remember. So the first part is, what is inferential statistics? It is a statistical method using which, okay, let's cut this down. This would be one. Statistical method using which inferences can be drawn. This would be our second part. What do you mean by inference? Inference means you are coming to a conclusion or this would be the findings of your study. You're deciding something, that's your inference. So the first part is statistical method using which inferences can be drawn. And what kind of inferences are you going to draw? About the population of the study. This would be your third part. Okay. So you are going to draw inferences about the population of the study based on the characteristics of the sample on whom the study was carried out. Okay, so let's meet this as the fourth one, based on the characteristics of the sample, 4 and 5 on whom the study was carried out. So if you can remember these 5 parts, it would be easy for you. The first part says that it's a statistical method using which, second part, inferences can be drawn. Inferences can be drawn about what? About the population of the study based on the characteristics of the sample on whom the study was carried out. So if the population is large enough, you will be choosing a sample from the population and conducting your study on the sample. Whatever your result you are getting on the sample, you will be projecting that or generalizing that into about the population. This is what this definition means. The second definition was given by Veera Raghavan and Chet Govekar in 2016. It says inferential statistics refers to the mathematical methods based on probability theory and helps in reasoning and inferring the characteristic features of the sample drawn from the larger population. Let's break down this also. Here it says inferential statistics refers to, let this be our first part, refers to what? The mathematical methods. Okay, this would be our second part. So, what is inferential statistics? Inferential statistics refers to the mathematical methods. What kind of mathematical methods? Based on probability theory. Okay, what kind of mathematical methods? The mathematical methods based on probability theory. So, this would be our third part. Okay, and what do these mathematical methods do? And helps in reasoning and inferring. It helps in reasoning and inferring. This would be our fourth part. Reasoning and inferring what? The characteristic features of the sample. This would be our fifth part. Okay. Sample, which sample? The sample that was drawn from the larger population. So, what is inferential statistics according to Veeraraghavan and Shedgovekar? Inferential statistics refers to the mathematical methods based on probability theory and helps in reasoning and inferring the characteristic features of the sample drawn from the larger population. We have two more definitions. The third one was given by Aaron and Coops, 2013. It says inferential statistics is employed by psychologists in order to make inferences and draw conclusions based on the certain data. This would be easier for you to remember. So what does it say? Inferential statistics is employed by psychologists for what? In order to make inferences and draw conclusions. Inferences and draw conclusions based on certain data. The fourth definition was given by King and Minium in 2008. It says the purpose of inferential statistics is to draw conclusions about the conditions that exist in a population from a study of a sample. So let's break down this also. What does it say? It says purpose of inferential statistics. What is the purpose? To draw conclusions. About what? About the conditions. Which conditions? That exist in a population. This would be a fourth part. From study of a sample. Okay. So King and Minium say that the purpose of inferential statistics is to draw conclusions about the condition that exists in a population from study of a sample. These were the definitions of inferential statistics. Now that we have looked at what inferential statistics is, let's look at the process of inferential statistics. How do we do inferential statistics? So the first step is selection of representative sample. Once you have decided the aim or the objective of your study, like what would be your topic, okay? So your next step would be finalizing the sample from the population which is under study. So this is selection of representative population. After you select the sample, then you have to collect the data, okay? So the selection of sample from the population should be random. This is one of the major rules of statistics, that the random sampling should be done from the population, and then you have to collect the data from your random sample. Then after collecting the data, you have to analyze the data. For that you can decide what kind of statistical tools you need to use. And then the last step is to draw conclusions and make inferences about the population. So at the end of the data analysis, whatever result you get, you have to draw conclusions about your research problem, and then whatever you get for the sample, you have to generalize that for the whole population. Next, procedures of inferential statistics. So earlier what you saw was what were the processes that you do. Okay, these are the two major procedures of inferential statistics that you're going to look at. First is estimation and second is hypothesis testing. So in case you get question on what are the procedures of inferential statistics, remember you have to write about estimation and hypothesis testing. In case you are being asked about the processes or the processes that are step-by-step process of inferential statistics, you have to write what we studied a second back. Okay, so let's look at the procedures. The first procedure is estimation. Estimation is estimating probability of a phenomenon. This definition was given by So this definition sounds very easy, that estimating probability of a phenomenon is referred to as estimation. So in simple language, estimating means you are calculating something, okay, or you have all the data and you are making an educated guess about something. This is called estimating. So you are finding out the probability of a phenomenon, or what is the chance that something can happen. This is referred to as estimation. There are two types of estimates: point estimation and interval estimation. First is point estimation. So what is point estimation? It is estimation in which a single value is calculated from the sample data and is used to estimate an unknown population parameter. So as the name suggests, there is a single point or a single value that is calculated from the sample data. And what is this used for? This is used to estimate an unknown population parameter. So you have selected a sample, you are calculating a value, single value, and that particular single value you are using to estimate or to make an educated guess or judge about the unknown population parameter. The two main point estimates are sample mean and sample proportion. The limitation is that a point estimate is a single value. So it's possible that the true population parameter is not equal to the point estimate. This can happen if the sample does not represent the true population, in which case calculating a point estimate will give you a false result. The second is interval estimation. As the name suggests, here there is not a point, it's not a single point, there is a range, there is an interval involved. Estimation which provides a range of possible values for that parameter, often with a specified level of confidence. We'll see what level of confidence is later in the video. For now, just need to understand this, that interval estimation provides a range of possible values for that parameter, often with a specified level of confidence. As the estimate is an interval, it can be taken that the estimate is close to the population value with 95 to 99% level of confidence. So you can be sure 95% or 99% that the population value will fall within the range of the interval estimate. The two main interval estimates are confidence interval for mean and confidence interval for proportions. Fluctuations or errors can happen in estimation due to two factors. One is chance factors, second is sampling errors. So chance factors, nobody can control them. It's unpredictable. It can be due to any reason. So when you are doing a research study, there is nothing you can do to avoid chance factors because it's beyond the control of the researcher. The second thing, sampling error, is very well within the control of the researcher. If you are not using random sampling techniques and you're using your bias to choose a sample from the population, this is how you invite sampling errors. And since it is very well in the hands of the researcher, the sampling error can be avoided by random sampling and using a large sample size. The second procedure is hypothesis testing. What is hypothesis? Hypothesis is a tentative statement that is investigated during the process of research. So the first step in any research is formulating a hypothesis. You need to say what exactly you are trying to study. This is a tentative statement that is investigated during the process of research. And what is hypothesis testing? Again, we have a textbook definition given by Veer Raghavan and Chet Govekar, 2016. This says a process involving statistical decision making with regard to population value that is based on the sample value. Hypothesis testing is defined as a process. Which process? Involving statistical decision making. Third, with regard to population value that is based on the sample value. Okay, so we have broken down the definition. Hypothesis testing is defined as a process What kind of process? One that involves statistical decision making. About what? With regard to population value based on sample value. Okay. Now we have two major types of hypothesis. The first is null hypothesis and the second is alternative hypothesis. So in our previous videos where we were calculating one-way ANOVA and then later on Kruskal-Wallis ANOVA, the first step in the computation was to formulate the hypothesis. And in all of those cases, we formulated two types of hypothesis. The first one was the null hypothesis and the second one was the alternative hypothesis. Let's see what those are. Hypothesis that states that there is no significant difference between the groups under study or there is no significant relationship between the variables under study. This is null hypothesis. Null means there's nothing, no, zero. Okay, that's what the hypothesis also say, that there is no point in you continuing the study. You don't need to do the study because there is no significant difference between the groups under the study or no significant relationship between the variables that you have chosen for your study. It is denoted by H0. Okay, so to continuing your study or research, you have to reject the null hypothesis. If the null hypothesis is accepted, there is no point in you continuing the research. And next is alternative hypothesis. There is exactly opposite of the null hypothesis. Alternative hypothesis states that there is a significant difference between the groups under study or there is a significant relationship between the variables under study. Okay, it's denoted by HA. A stands for alternative. This is also called research hypothesis because when you are continuing with your research, you have to prove that your alternative hypothesis is correct or you have to accept the alternative hypothesis in order for your study to progress. It may be directional or it may be non-directional. So let me give you an example here. I want to study the relationship between motivation and performance in classes. Performance in class. Okay. So if I want to study the relationship between the motivation of a student and the student's performance in class, my null hypothesis would say don't go ahead with the study because there is no significant difference or relationship between motivation and performance in class. Okay. My alternative hypothesis would say, yeah, go ahead, continue with the study because there is a significant relationship between motivation and performance in class. So when I'm saying that there is a significant relationship between motivation and performance in class, I'm saying that there is a relationship, but I'm not saying what the relationship is. Like if the more motivation will positively affect the performance or lack of motivation does not, results in less performance in class. I'm not saying what is the relationship, but I'm saying there is a relationship. This is called non-directional hypothesis. I am not stating any direction or any particular relationship that is there between my variables. Okay. Now, if I am saying that motivation has a effect on performance in class and more the motivation, more is the performance in class, I'm giving a direction to that hypothesis. Okay, like this is what the root of study should be, that more the motivation, better is the performance in class. This is called directional hypothesis. Now that we have seen what null hypothesis and what alternative hypothesis is, let's differentiate between those. This is also an important question that comes in the exam, to differentiate between null hypothesis and alternative hypothesis. So the first point states that the presence of equality between groups. In null hypothesis says there is a presence of equality between the groups, which means there is no difference between two groups, both are equal. Okay. Alternative hypothesis states the presence of inequality between the groups. It says there is a significant difference between the groups, so they are not equal. So the first one, null hypothesis, states the presence of equality between the groups, and alternative hypothesis states the presence of inequality between the group. According to null hypothesis, there is no significant relationship or difference between variables or groups respectively, which means there is no significant relationship between the variables or no difference between the groups under study. And in alternative hypothesis, there is a significant relationship between the variables or there is a significant difference between the groups under study. Null hypothesis can be tested indirectly only, while alternative hypothesis can be tested directly. What does this mean? So null hypothesis you cannot test directly, you have to reject it. You reject the null hypothesis while you test the alternative hypothesis directly, and if it is accepted, null hypothesis is automatically rejected. Okay, so whenever you're doing the hypothesis testing, you are testing the alternative hypothesis, and if that is accepted, null hypothesis is automatically rejected, and if alternative hypothesis is rejected, then your null hypothesis is automatically accepted. Null hypothesis denoted by Greek symbol such as mu. This is start from mean. And alternative hypothesis denoted by Roman symbol such as x and n. Null hypothesis is an implied hypothesis as it cannot be tested directly. This is an implied hypothesis. As I said, if alternative hypothesis is accepted, it is implied that null hypothesis is rejected, and vice versa. While alternative hypothesis is explicit hypothesis as it can be tested directly. These are the differences between null hypothesis and alternative hypothesis which you need to remember. Let's now see what the characteristics of a good hypothesis are. The first characteristic of a good hypothesis is that it should be in a declarative form. What is a declarative form? Where you are declaring something. It's a concrete statement where you are saying that there is a relationship between the student's motivation and his or her performance in the class. I'm not asking a question in hypothesis. Like, is there a relationship between the student's motivation and his or her performance? No, I'm not asking a question. I'm saying, yeah, there is a relationship. This is what is called a declarative form. Okay. The second characteristic says it states a relationship that is expected between the given variables. Exactly the same example. I'm saying that there is a relationship between the motivation of the student and his or her performance in the class. It should not be in a null hypothesis format which says that there is no significant relationship. No. If you're saying it in a null format, it's not a good hypothesis. The third one says the theory or literature on the basis of which the hypothesis is formulated should be reflected in that hypothesis. Okay, so whatever your research wants to study or the theory that your research is trying to test or prove or disprove, it should be reflected in the hypothesis. For example, I want to study how motivation helps in class performance. So this should be reflected in my hypothesis. These two words, the key words, that is motivation and performance. It should be there in my hypothesis also. The fourth characteristic of a good hypothesis is that it should be clear and to the point. No beating around the bush. Shorter, sweeter, clear and to the point. The last one, it should be testable. So the whole point of hypothesis testing is we should be able to test the hypothesis. Only if your null hypothesis is rejected. How? By accepting the alternative hypothesis. Only then you can continue with the study. So your hypothesis should be testable for it to be a good hypothesis. Next, level of significance. This is one of the important concepts that are involved in hypothesis testing. Now, what is a level of significance? This is denoted by alpha. Okay. The level of significance is a threshold, usually set at 5%, which means 0.05, or 1%, 0.01, that researchers use to determine whether their results are statistically significant or not. Or simply saying, we are saying that there is a 95% chance that whatever results I have got is statistically significant and correct. Or I'm saying there is a 99% chance that my results are correct. Okay, I am leaving there a 5% chance that there could be something wrong, or a 1% chance that there could be something actually wrong in my research. So the probability of incorrectly rejecting the null hypothesis when it's actually true. Okay. Incorrectly rejecting the null hypothesis. If you are incorrectly rejecting the null hypothesis, which should have been accepted, this means your study is going to be a fruitless exercise. You're not going to get anything out of it. There was actually no relationship, but instead of accepting the null hypothesis, you're rejecting the null hypothesis when it's actually true that there is actually no relationship between your variables. Okay. It helps researchers decide if the observed effect is likely due to a chance or a real phenomenon. So setting a level of significance, it helps the researcher to make sure that whatever result they have got is actually due to a real phenomenon and not because of a chance or something that happened by mistake. Okay. Alpha value 0.05. What is meant by alpha value of 0.05 or 5% confident level of significance? There is a 5% chance of incorrectly rejecting the null hypothesis. Okay. When you are setting your alpha value at 0.05, this means there is a 5% chance that you are incorrectly rejecting the null hypothesis. You should not have continued with the study, but you are still choosing to continue with the study. Alpha value of 0.01 or 1%. This is a stricter threshold requiring stronger evidence to reject the null hypothesis, which means there is a 1% chance of incorrectly rejecting the null hypothesis. Okay. I hope you understood this concept, level of significance. Level of significance is the chance that whatever study you are doing could be wrong. There could be some error. There is like if you are saying my level of significance is 5%, your confident level is 95%. The 95% chance that you are doing everything correct, and there is a 5% chance that your results are wrong. It could be because of chance or a random incidence. Okay. If your alpha value or level of significance is 1%, this means there is a 99% confidence. You can have 99% confidence that your study is in good shape. You're doing all correct. And there's a 1% chance that it could be some error or random phenomena. Okay, I hope you understood because this is a very important concept. Whether the null hypothesis is accepted or rejected will depend on whether the statistical value obtained after the data analysis is more or less than the table value specified at 0.05 or 0.01 level of significance. Now, if you remember the video for one-way ANOVA, after we calculated the first question, I showed you a table. Okay, you got a calculated value, and then using the degrees of freedom, you are finding a table value. Okay, for every statistical technique that you are using, there would be a table at the end of the textbook where you will find certain values, the critical values. So you have to compare your calculated value with the critical value to know whether to accept the null hypothesis or reject the null hypothesis. Okay, and when you are checking out the table value, you will have two types of table values, one at 0.05 level of confidence and one at 0.01 level of confidence. There could be some at 0.005 and 0.001 also. Okay, so whether the null hypothesis is accepted or rejected will depend on whether the statistical value that you have obtained from your calculation after the data analysis is more or less than the table value specified at 0.05 or 0.01 level of confidence. If the obtained value is higher than the table value, then the null hypothesis is rejected. If the obtained value is less than the table value, then the null hypothesis is accepted. Okay, this is something that you need to remember. If the obtained value is higher than the table value, the null hypothesis is rejected. If the obtained value is less than the table value, then the null hypothesis is accepted. So, under hypothesis testing, there are two types of tests. One is one-tailed test and the other is two-tailed test. This is based on the alternative hypothesis that you are testing. When we were discussing alternative hypothesis, I told you that there are two types of alternative hypothesis. One is directional and one is non-directional. So when your hypothesis is directional, we use one-tailed test. What was directional hypothesis? Where you are specifying a direction or a specific relationship between your variables. For example, you are testing the efficacy of a new drug on blood pressure. Okay, so you are saying that this particular drug has a positive influence on the blood pressure, or it decreases the blood pressure. So you're giving a particular direction to that test. This is one tail test. Or you can also say that this particular test increases the blood pressure. That is, it has a negative outcome on the blood pressure of a person. Here also you are giving it a particular direction. So this is called directional test or one tail test. Why do you call it one tail? Because your critical region will fall on one side of your plot or the curve. Okay, so here if you see, this is the graph and this is your critical region. What is the importance of critical region? Your calculated value should fall within this critical region for you to accept the alternative hypothesis. If it falls anywhere here, your null hypothesis gets accepted, which means there is no point in continuing the study. Okay, so what does one-tail test do? It checks for a difference in one direction. It tests whether a sample mean is significantly greater than or less than the population mean. If it is greater than, then it will be the critical region will fall on the right side, in which case you call it a right-tailed test. If your sample mean is less than the population mean, then the critical region will fall on the left side. We call it a left-tailed test. Okay. So in this case, your calculated value should fall in this region for your alternative hypothesis to be accepted. Anywhere else, the null hypothesis is accepted. So in one-tail test, the alternative hypothesis specifies a direction. Only one tail of the distribution is considered for the critical region. This we have already seen in this graph. In case of a two-tailed test, we know that the hypothesis would be non-directional one. So this is a non-directional test where you are specifying a relationship between the two variables, but you are not giving it a particular direction. Like if the drug is going to increase the blood pressure or decrease the blood pressure. You are just saying that the drug has a significant effect on the blood pressure. This is non-directional hypothesis. So it checks for a difference in either direction. When you are saying that the new drug has an effect on blood pressure, you can check whether it is going to increase the blood pressure or decrease the blood pressure because you don't know what the specific direction is. So you will be checking for both ways. So it tests whether a sample mean is significantly different from the population mean without specifying the direction of the difference. So you know there is some difference, but you don't know what the difference is. So you will check for the difference. The alternative hypothesis does not specify a direction. Both tails of the distribution are considered for critical region. So your critical region can fall on both sides of the curve. Okay. So what does this mean? If you have a critical region of level of significance of 0.05, half of this would fall on this side, half of this would fall on this side. So if your calculated value falls in this region, then you accept your alternative hypothesis and go ahead with your study. And if it falls anywhere else, then your null hypothesis is accepted and you just stop the study. Okay, so this was one-tail test and two-tail tests. Next, we have errors in hypothesis testing. So what are we doing right now? We are learning the two main procedures that are involved in inferential statistics. One was estimation and second was hypothesis testing. Under hypothesis testing, before we actually learn how to test the hypothesis, we need to know certain concepts which we are studying right now. So what are those concepts that we have studied till now? What is a hypothesis? What are the two types of hypothesis? Null hypothesis and alternative hypothesis. What are the differences between the null hypothesis and alternative hypothesis? What is the level of significance? And last we learned two types of tests, the one-tailed test and two-tailed test. Now we have errors in hypothesis testing. What are the types of errors that can happen while you are testing a hypothesis? The first one is type 1 error. The second one is type 2 error. Pretty easy names to remember. So a type 1 error says when a null hypothesis that is actually true is rejected. When is a null hypothesis true? When there is no significant relationship between the variables that are under study. Okay, so the example that we used, if there is no relationship between the motivation of the student and the performance in the class, that's a null hypothesis. And in the second example that we used, if there is no significant impact of the drug on blood pressure, even in that case, the null hypothesis is true. When the null hypothesis is true, you need to accept the null hypothesis and stop the study. But instead, if you're going to reject the null hypothesis and go ahead with the study, that's when type 1 error happens. Okay. So under what conditions do type 1 error happen? It happens when the level of significance used to reject the null hypothesis is high. If you're using a higher level of significance, there is a good chance that you end up with a type 1 error. Okay. Next, type 2 error happens when a null hypothesis that is actually false is accepted. Okay, this is also not a good case. So when is a null hypothesis actually false? What does a null hypothesis say? Null hypothesis says the hypothesis says that there is no significant difference between your variables. So it would be false when there is actually a significant difference and you are saying that no, there is no significant difference. Okay, and in such a case, when you are accepting a false null hypothesis, you will end up stopping the study, which would be a loss of all the resources and time you spent on it, while you should have actually gone ahead with it because there was actually a significant difference. Okay, so in the first case, the null hypothesis, which is actually true, gets rejected, which means there is actually no relationship, but you are saying that there is a relationship and then you are continuing with the study. And in the second case, null hypothesis that is actually false is accepted, which means actually there is a difference between your variables, but you are saying that there is no significant difference and you are accepting that false null hypothesis. Okay, and this happens when the level of significant use is very stringent. Very stringent means what? Very strict. You're using a very strict level of significance. In that case, you end up with a type 2 error. Another error that you need to know is standard error. Okay, now what is standard error? Standard error is the standard deviation of all the standard deviations computed for given number of samples randomly drawn from the same population. I would say you should go and refer back to the one-way ANOVA video because there I am explaining in detail what standard deviation and variance is. I'll add the link in the description. I think I referred to the same video before also regarding hypothesis. Yeah. So standard deviation. So standard error is standard deviation of all the standard deviations computed for given number of samples randomly drawn from same population. So you have one single population and you are drawing A, B, C, D, 4 random samples. Okay, and then you are calculating standard deviation from this sample, standard deviation from sample B, standard deviation from sample C, and standard deviation from sample D. Okay, and then you were calculating a super standard deviation, like the standard deviation of all these individual standard deviations. Okay, and that would give you the standard error. I hope that makes it easy to understand. You are drawing multiple samples from the same population. Then you are calculating the individual standard deviations. And then you are calculating the standard deviation of all those individual standard deviations, which gives you a standard error. Okay. And what the standard error does? It measures error of sampling and it measures error of measurement. So all the standard deviations will give you all the errors that has happened while you were selecting the sample and all the errors that has happened while you were measuring the parameters. Higher the standard error, less the likelihood that the sample is representative of the population. So we said that it measures error in sampling. So if the standard error is high, this means the sample that you have selected does not represent the population in true sense. The difference between the sample needs to be close to 0 for them to represent the population. So we said standard deviation. The difference or the variance between all these groups should be close to 0 for them to represent the population. Mathematically, standard error can be said as sigma divided by root of n, where sigma is standard deviation of the sample mean and n is the number of cases in the sample. Now the concept that we need to know is degree of freedom. Degrees of freedom is also a concept that I have explained in detail in the one-way ANOVA video. So I request you all to go and watch that first before you come to this video. I'll add the link in the description for your ease. So degrees of freedom are the maximum number of logically independent values which may vary in a data sample. The degrees of freedom are calculated by subtracting 1 from the number of items within the data sample. So degree of freedom would be 1 minus the number of items in the data sample. So yeah, I would suggest you go back and watch the video because there I'm explaining degree of freedom with an example and an analogy. It's the maximum number of logically independent values which may vary in a data sample. The last concept before we learn hypothesis testing is power of a test. Power of a test is a measure of how sensitive the experiment or research is in detecting the real effect that the independent variable has on the dependent variable. This definition was given by Mohanty and Mishra in 2016. So let's break down the definition. So it says power of a test is measure of what? How sensitive the experiment or research is. In sensitive in what? In detecting the real effect. Real effect of what? The independent variable. Real effect that the independent variable has on the dependent variable. So we have 4 parts to this. Power of a test is a measure of how sensitive the experiment or research is in detecting the real effect that the independent variable has on the dependent variable. Power is equal to 1 minus probability of type 2 error. We already learnt what type 1 and type 2 error is. Power would be 1 minus probability of type 2 error. Power of a test can also be described as probability of rejecting a null hypothesis that is actually false. The values of probability ranges from 0 to 1. So this is something that we have learnt in our mathematics class in school, that value of probability always falls between 0 and 1, not beyond and not beyond. More is the p-value or the power of a test, more the experiment or research will be sensitive in detecting the real effect. Less is the value, less is the experiment or research sensitive in detecting the real effect. And as the sample size increases, the power of a test will also increase. So I think by name itself we know the power of a test is how efficient the test is for detecting whatever the variables are under study, the relationship between variables under study. Okay. And finally we are here. The steps in hypothesis testing. So we have deviated a lot. We have learnt a lot of things after we completed estimation before we reached what is hypothesis testing. We have learnt what is hypothesis and everything that you need to test a hypothesis. So the first step is null hypothesis and alternative hypothesis is formulated. By now we know what is a null hypothesis. We know what is an alternative hypothesis. So the first step in hypothesis testing is to formulate a null hypothesis and an alternative hypothesis. The second step is a level of significance is selected. We want to see if we want to keep 95% level, 99% confidence level, okay, or 0.05 or 0.01 level of significance. This was the alpha value. So this is the alpha value 0.05, 0.01. This we call confidence level, like how confident we are about our study. Okay, and this is how much chance of error is there. Okay, so third step, based on the parameters specified in the null hypothesis, a suitable statistic is calculated. You decide what kind of a test you want to do. Do you want to calculate an ANOVA? Do you want to calculate a chi-square? Do you want to do a Mann-Whitney or you want to do a t-test? You decide the statistic that you want to calculate based on the parameter. And then you check the critical value or the table value, and the decision is made whether to accept or reject the null hypothesis. So these are the four important steps that are there in the hypothesis testing. What was it? First, we formulate the hypothesis. Next, we decide a level of significance or the alpha value. Then based on the parameter, you calculate your suitable statistic. Then you make a decision whether to accept or reject the null hypothesis. So this was the theory part that you need to know about inferential statistics. Next, we have a previous year question. We'll discuss some of the previous year questions. So the first one that I wanted to discuss is June 2024 ka question that says, describe the fundamental concepts in determining the significance of difference between means. Why am I discussing this question separately? Is because this question is from block 2. Okay. Block 2, there is a topic, difference between means. This question is from that part. It says, describe the fundamental concepts in determining the significance of the difference between means. And these are the concepts that we have already studied. So I will not be taking the second block separately. If you get such a question, this has already come in June 2024. If you also get this, you have to write these concepts. The concept that you have to involve is null hypothesis, standard error, degrees of freedom, level of significance, one-tailed and two-tailed tests of significance, errors in testing. This is a 10-mark question. If you write about all of these, you easily score 10 marks. Okay. Let's look at the other questions that have come. The latest one, December 2024. The question that came is, write short notes on the following in about 150 words each, 5 plus 5. The difference between null and alternate hypothesis. Sorry, this should be alternative hypothesis. And standard error. So you have to write 150 words on each of these. You get 10 marks. June 2024, another question came. Explain the meaning of inferential statistics. I've already told you 4 different definitions. You can learn any of those and you can write the concept also. Describe the procedure for testing the hypothesis. We know the procedures which are tested for which you have to write. One is estimation and another is hypothesis testing. So if you write both these procedures, you will get full marks. June 2023, same question for 10 marks. So 2024 you had the question for 5 marks where you had to write, describe the procedure for testing the hypothesis for 5 marks. The same question has come for 10 marks. Explain the procedures under inferential statistics. Okay, so you can just explain and elaborate as you want for the 10 marks, but the key points remain the same. December 2022, the question came, explain the concept of inferential statistics and describe the inferential procedures. Same question. Okay, you have to write the definitions and before that what inferential statistics is, and then the different inferential procedures, which is estimation and hypothesis testing. June 2022, write short notes on the following in about 150 words each. First was estimation and the second is errors in hypothesis testing. December 2021, the question came, explain the concept and meaning of inferential statistics. Describe hypothesis testing in inferential statistics. So we have pretty much covered everything in this video that can potentially come from this unit. And you have seen it definitely comes in every previous year question paper. Okay, so make sure you go through this video, study it well. In case you have any doubt, free feel to put it in the comments. I'll make sure that I come back and revert to you. So this was all about inferential statistics. If you understood everything, as I said, like the video and let me know. In case of any doubt, write to me and subscribe to know when I'm going to put the next video. I think this would be the last of stats video. In case you feel you want any other topic, feel free to write to me and share it with your friends so that they also learn some amazing concepts from statistical psychology, use of stats in psychology. Okay, so yeah, that was all for today. Keep learning with me. Take care. Bye-bye.